Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about dynamics of rigid bodies. At ngayon guys ay magkakaroon tayo ng discussions about curvilinear motions. Sa huling bahagi nitong discussions ay meron tayong inihandang tatlong sample problem para makatulong sa atin upang lalong maintindihan itong ating topic na curvilinear motions. So bago tayo mag-start guys ay puntahan muna natin itong mga ilang konsepto na pwede natin maging gabay in working with curvilinear motion. Sinasabi dito na kung yun daw epekto ng mga factors such as the wind velocity o kaya yung air resistance o kaya yung rotation of the earth will be assumed negligible. Then, the curvilinear motion of a particle along its path may be resolved along the x and y components having an origin at the initial point. So, ang ibig sabihin nito, guys, ay ganito. Kung sakali na yung mga factors na nakaka-apekto ng motion ng a particle will be assumed negligible, then we can resolve the elements of the motion along its path into its x and y components. And so, kung meron tayo halimbawa dito particle at point O, and this point O is given an initial velocity, okay, and travels this path. Ang ibig sabihin nito, at any position, particular position along its path, we can resolve the elements of the motion in the horizontal and vertical components or in the x and the y direction. So that if I have here the initial velocity, so at the origin, we can resolve this initial velocity into x and y component. Diba? So sabihin natin that after some elapsed time, the particle is already somewhere here at point A. And at point A, the velocity changes, the direction also have changed, okay? And assuming that this velocity now becomes the velocity of the particle at point A, then the velocity of this particle can be resolved also in terms of the horizontal or the x component and the y component of the particle. Ganun din, if this particle will be found at another position, say for example at point B, na kung saan ang kanyang velocity na is defined here by a v sub b, then this velocity can also be resolved into x component so that you have v sub b sub x and v sub b sub y. And then also finally at the end point where the velocity is considered to be a v sub c, this v sub c can be resolved into components so that you have v sub c sub x and v sub c sub y. So sabi dito, from the initial direction of the motion from here, the rectilinear displacement will be positive, okay, if it is both directed in the rightward and the upward direction. Halimbawa sabihin natin, at after some time, okay, the particle is already at point A where it is already above the original position at O. Therefore, the displacement at point A will be treated to be positive kasi ang kanyang naging position is above. While it has moved to the right, therefore, along the x-axis, the rectilinear displacement will also be positive. If after some another time, the position is already at C, you will notice that C is already below the original position at O. Then the displacement from O to C will be now considered to be negative because it is directed in the downward direction. But still, the horizontal displacement will still be positive because it is found at the right of the original position. And hence, if both acceleration in the x and y directions are constant, sabi dito, then the equation of rectilinear motion with constant acceleration, okay, may be used to determine the rectangular components of the curvilinear motion. Kaya nga daw kung yung ating acceleration will be constant, then the rectilinear motion with constant acceleration can be used in defining the elements of the motion of the particle when the particle moves in a curvilinear motion, okay, using the concept of the rectilinear motion. So, kumbaga, ipapakita natin ito yung konsepto na halimbawa ito yung ating a rectilinear motion with constant acceleration. Alam naman natin, basically, meron tayong a velocity which can be the final velocity which can be computed using the formula that it is equal to the initial velocity plus the product of the acceleration multiplied by the time. Okay, so if we are going to consider the x component of the flight, and we wanted to determine the final velocity, therefore the final velocity shall be considered to be the initial velocity along the x plus the acceleration along the x multiplied by the time t, na kung saan dito yung v sub ox is equal to v sub o multiplied by the cosine of the angle theta. Ito yung nakikita natin dito, na kung saan itong v sub ox will be the x component of v sub o, which is equal to v sub o multiplied by the cosine of this angle theta. Okay, at kung pag-uusapan naman natin ay yung kanyang y component of the curvilinear motion, yung v sub y naman natin will be equal to v sub oy plus ay multiplied by t, na kung saan naman ang v sub oy naman will be equal to the y component of this v sub o, and this is equal to v sub o multiplied by sine of the angle theta. Ngayon, ganun din kapag kinocompute natin yung kanyang displacement. Alam naman natin yung displacement is computed using the rectilinear motion having constant acceleration such that s is equal to v sub ot plus 1/2 of at squared, where v sub o is the initial velocity and a is the acceleration. If this is to be used in the curvilinear motion, then we can use the components of the elements in the x, okay, such that the x distance traveled by the particle will be equal to v sub ox multiplied by t plus 1/2 of a sub x multiplied by t squared, na kung saan uli yung v sub ox will be equal to b cosine of theta. Ganun pa rin yung kanyang horizontal component of the velocity is equal to v sub o multiplied by the cosine of theta. If we are to talk about the vertical component of the distance traveled by the particle represented by f sub y, s sub y will be equal to v sub oy multiplied by t plus 1/2 a sub y multiplied by t squared, wherein yung ating v sub y again is equal to the initial velocity multiplied by the sine of the angle theta. So bali ganun lang ang mangyayari kung constant din lamang yung acceleration, then we can use the rectilinear motion with constant acceleration in dealing with curvilinear motion. Ang pinaka-sekreto lang doon is we will be resolving all the components along the x and along the y, and we analyze the x components of the motion and the y components of the motion. Para maipakita natin guys yung konsepto na niliwanag ko, ay subukan natin itong isang sample problem about curvilinear motion. And the problem is here, sabi dito, a stone is thrown from the top of a building 25 meters high, having an initial velocity of 20 meters per second, directed up at 40 degrees from the horizontal. From here, we are required to find for the distance from the building at which the stone will strike the ground. So, para makita natin, mas maganda siguro ay isa-isahin natin yung given. And then from the given, we try to draw the illustration. So, binabanggit dito na meron ditong building 25 meters high. And then a stone is thrown from that building. So, let us imagine na meron tayo ditong building. Itong building na ito ay 25 meters high. Ito halimbawa, sabihin natin yung stone. Ayan. This stone is given an initial velocity of 20 meters per second up to the right at an angle of 40 degrees from the horizontal. So, assuming natin na ito yung ating origin, and then from the origin, we consider the x-axis. We also treat here our y-axis, and let us imagine that this is our origin. Then there is the stone that is thrown at an initial velocity v sub o, given to be 20 meters per second. The inclination of this velocity is 40 degrees away from the horizontal. And from here, we are required at what distance from this building will this stone will strike the ground. Diba? So, yun ang pinapahanap sa atin. So, kumbaga, if we are going to show again how the stone will travel. Okay? So, ito yung mangyayari kasi yung kanyang path na travel niya kapag ibinato siya. At yung sinasabi natin, how far the distance from the building at which the stone will strike the ground ay itong distance na mula dito sa building ito hanggang dito. Ito yung tinatawag natin at sabihin natin siya ay S sub x. Okay? So, sa ganun rin klase ng problem, makatutulong na i-analyze natin ano yung mga helpful tips in solving projectile motion. Ito naman ay kung sakaling ayaw mo na magmemorya ng maraming formula. Ano? May mga pagkakataon kasi na dahil nga sa dami ng formula, no overload tayo pero hindi naman kailangan natin memoryahin lahat ng formula. Ang mahalaga ay naiintindihan natin yung konsepto. Ano? So in here, mas makatutulong kung itong ating mga elements ng motions, ano? Yung acceleration, velocity at displacement ay ma-resolve natin into the respective components, yung x and y component. Kaya kung meron tayo dito velocity, so identify natin yung kanyang component in the x, tawagin natin siyang b sub ox. At yung kanyang component in the y, b sub oy. Diba? Ganon din dito, kung ito yung kanyang velocity, just in case that we will be needing this one, ano? Yung kanyang x component ng velocity and the y component of this velocity. So pagkatapos natin ma-identify yung kanyang mga components, ano, ay identify naman natin yung mga magnitudes ng components kung given at ipakita natin kung ano ba yung hinahanap. Diba? So sabi dito, we identify the magnitudes of the component of each element using the convention. So kinakailangan natin mag-establish tayo ng convention. Ano? At ano ba yung common convention? Yung ginagamit kasi natin, if the direction is rightwards and upwards, we consider that as positive. Ganon din sa position. If the position is to the right or upward of the original position, then we consider that as positive. The other position or direction will therefore be considered to be negative. Diba? So, ipakita natin dito, kung ito yung kanyang direction of initial position at ito yung final position, therefore this distance will be the displacement in the y direction at tawagin natin siyang s sub y. And what will be the magnitude? Since the building is 25 meters, hence this value will be 25. But in the computation, we will be considered it as negative 25. Ano? Okay? So, ganoon dito, yung kanyang s sub x will be this value. Okay? And it will be positive because it is located to the right of the building. Kaya from here, okay, maintindihan natin na as the particle moves from the original position to the final position, although the particle moves upward and then downward, the total displacement shall be represented here by s sub y. At binabanggit dito daw yung total time required for the particle to have the horizontal component of the displacement, itong time required to travel this distance s sub x, is equal to the time required for the same particle to travel the y component of the displacement or s sub y. And itong basic relation ito yung ating gagamitin in order for us to solve for this s sub x. Pero mag-start tayo with those directions that are available, that are complete. Okay, and so makikita natin dito that from here we can compute for the total time that this stone will be needing in traveling a total displacement of 25, because we can have it using the y component of the motion, that is equal to s sub y equal to v sub oy multiplied by t plus 1/2 of ay multiplied by t squared. So kinakailangan dito ay maintindihan natin, ma-define natin yung mga values. So sabi ko nga kanina, itong ating s sub y will be negative kasi yung kanyang final position will be below the original position, and therefore this distance must be treated as negative. That is for the convention na binabanggit natin dito. So sabi dito, negative is used because the final position is below the original position, which is assumed to be the origin of the Cartesian plane. Ito kasi yung ating original position will be treated as the origin of the Cartesian plane. So what else? So yung ating b sub oy dito na binabanggit dito, will be equal to the vertical component of the velocity, which is equal to 20 multiplied by sine of 40. And this will be positive because the direction is upward. As the convention says a rightward and upward direction shall be positive. Okay, similarly, yung ating a sub y ay will be considered to be negative. Negative 9.81 meter per second square. Bakit? Kasi nga, yung kanyang direction is downward. Ba? And all the downward direction will be treated as negative for that particular convention. And so from here, okay, masosolve na natin itong ating time required for this stone to hit the ground. And so if we are going to substitute that value, okay, what do we have? We will have S sub y, which is equal to b sub oy multiplied by t plus 1/2 of a sub y times t square. So we shall have a value here. Kapag sinubstitute natin yung mga value, makukomplete natin yung t na 3.921 second. Ibig sabihin, 3.921 second after the stone is released from the top of the building, it will now hit the ground. And it is the same time that the stone will travel a total distance of s sub x. Hence, we can now use the y-x component of the motion in order for us to solve for this s sub x. Kaya nga, if we are to substitute that formula, those value in the formula, that s sub x is equal to b sub ox multiplied by t plus 1/2 of ax multiplied by t squared. In this particular case, yung ating ax will be considered to be 0 kasi there is no mention of any factors that may affect the motion of the stone. Hence, this component, a sub x will be 0. A sub x multiplied by t square will be equal to 0. Kaya nga kapag isasubstitute natin yung value ng t, which is 3.921 here, na kung saan ang kanyang horizontal component of the velocity will be equal to v sub o cosine of 40. So kapag sinubstitute natin dito, that is 20, which is the initial velocity, multiplied by cosine of 40, multiplied by 3.921 seconds, will give us a total distance equal to 60 meters. At ito yung sinasabi nating horizontal distance, or the distance at which the stone will strike the ground from that of the building. Sana guys ay nakita nyo kung paano tayo mag-deal ng curvilinear motion at kung paano natin gamitin yung konsepto ng rectilinear motion in solving problems that deals with curvilinear motion. Guys, pag nyo akong iwan, patuloy nyo akong subaybayan sa ginagawa natin discussions. Kaya naman ay suggest na mag-subscribe tayo ng channel nito so that anytime na meron tayong bagong upload ay ma-notify ka of these discussions. Once again, thank you very much for watching.